Hello, my name is Gabe. For this problem, we're given that cosine of theta equals 1/3, and we're asked to find sine of theta, tangent of theta, secant of theta, and cosecant of 90 degrees minus theta. To find sine of theta, we'll want to use one of the identities that relates sine and cosine. The identity that relates sine and cosine is the Pythagorean identity, which states that sine squared of theta plus cosine squared of theta equals 1. So since we know that cosine of theta is equal to 1/3, we can substitute this in and solve for sine of theta. So what we're left with is sine squared of theta plus 1/3 squared equals 1. Now 1/3 squared is 1/9, so we have sine squared of theta plus 1/9 is equal to 1. Now subtracting 1/9 from each side of the equation leaves us with sine squared of theta is equal to 8/9. And we can solve for sine by taking square roots of each side of our equation. And we'll want to be careful here. Because we're taking square roots of sine squared, normally we'd end up with a plus or minus. But in this case, since we're talking about sides of a right triangle, all of our side lengths are positive, so sine will be positive. So we're left with sine of theta is equal to 2 times the square root of 2, all divided by 3. For part B, we're asked to find tangent of theta. To find tangent of theta, we'll use the quotient identity, which states that tangent of theta is equal to sine of theta divided by cosine of theta. Since we already know that sine of theta is equal to 2 times the square root of 2 divided by 3, and cosine of theta is 1/3, we can substitute these values in, leaving us with tangent of theta is equal to 2 times the square root of 2 divided by 3, all divided by 1/3. And this simplifies to 2 times the square root of 2. So we have tangent of theta is equal to 2 times the square root of 2. To find secant of theta, we'll use the reciprocal identity, which states that secant of theta is equal to 1 divided by cosine of theta. And since we already know that cosine of theta is 1/3, we can substitute this in to find secant of theta. So substituting 1/3 in for cosine of theta, we have secant of theta is equal to 1 divided by 1/3, which is equal to 3. Finally, for part D, we're asked to find cosecant of 90 degrees minus theta. Here, we'll want to use the identity that states that cosecant of 90 degrees minus theta is equal to secant of theta. And since we've already found secant of theta to be equal to 3, we know that cosecant of 90 degrees minus theta is equal to 3. Thank you.